Hello everyone. This video is the video answer key to coordinate proofs 2 practice number 1. So in question number 1 we want the vertices of quadrilateral glove has coordinates of those, and we need to prove that it is a rectangle. I'm going to underline that so I can just remember which one that I'm proving. So rectangle. So if you recall from your list from the notes for coordinate 2, the first thing that we need to do if we're proving either a rectangle or a rhombus is the first thing we need to do is prove that it is a parallelogram. So that is our step number 1. Prove parallelogram. Parallelogram. And as we recall, that is two midpoint formulas to show that the diagonals bisect each other. So my diagonals, I am going to label these guys. So this is my x1, y1, and the other coordinate is O, so that's x2, y2. And if you need to draw a picture just so that you can see where these diagonals are, if you can't tell just by the the acronym itself. Every other one, so G, G, and then O, that's going to be a diagonal, and then L and V are going to be the other ones. So this is about a G and O, L and V. So every other one is going to be diagonals. Ones that are right next to each other, those are going to be sides. Okay? Or you can just draw a picture over here. So we got GO and then LV is my other one. I'll do that one in blue. So L, this is my X1 and Y1. This is my X2 and Y2. All right, here we go. So let's start with GO, my midpoint of GO. Just write this down, the formula, the average of my X's, comma, the average of my Y's. All right, now we plug in. X1 is -5, and we're adding 7. -5 plus 7 divided by 2. And then we got 0, and we are adding a -4, so 0 minus 4 divided by 2. This gives me a midpoint of -5 plus 7 is +2 divided by 2 is 1. 0 minus 4 is -4 divided by 2 is -2. All right. And now I gotta do the midpoint of LV. I won't write the formula this time because I already did once. -1 plus 3 for my x's, comma, my y's, -8 plus 4 divided by 2. This gives me a midpoint of -3, excuse me, -1 plus 3 is +2 divided by 2 is 1. That's good. -8 plus 4 is -4 divided by 2 is -2. Perfect. Both my diagonals have the same midpoint, and therefore they bisect each other. So now I need to write my sentences. So we have GLOV has diagonals that bisect each other. Therefore, quadrilateral glove is a parallelogram. Alrighty, step number 1, done. Step number 2, we're proving rectangle, so we need to either choose diagonals are congruent to each other, or that we need to show that there is one right angle, or in other words, consecutive sides are perpendicular to each other. Since we've already dealt with the diagonals, let's just keep going with the diagonals. So I'm going to show the diagonals are congruent. Oops. So step 2 is prove rectangle. All right, so like I said, I'm going to do the distance formula of my red diagonal, which was GO. And let's write down that distance formula, x2 minus x1 quantity squared, y2 minus y1 also quantity squared, all underneath a radical. All right, and let's just plug in here. My x2 for my reds is 7, and I am subtracting -5. So I got 7 subtract -5. Again, I put that -5 in parentheses so that I can see that I am subtracting a negative. Always a good habit. Now my y's. Y2 is -4, and I'm subtracting 0. Quantity squared, all underneath the radical. So 7 minus a -5 turns into 7 plus 5, which is 12, and 12 squared is 144. Add to that -4 minus 0, that's -4. -4 squared is 16, all underneath the radical. Add 144 and 16, and you get 160. All right, now let's do our distance formula of LV this time. Oops, LV. I won't write in the formula this time. I'll just plug in. So I got x2 for my blue, which is 3, and I'm subtracting a -1. Put that -1 in a parenthesis itself. And then I have my y's. My y2 is 4, and I'm subtracting -8. Quantity squared. All right, so now I got 3 minus -1. That turns into 3 plus 1. That is 4. 4 squared is 16. That's good because 16 was in the other one. 4 minus a -8 turns into 4 plus 8, which is 12. 12 squared is 144. Fantastic. That looks just like my other distance. And that also gives me a distance of radical 160. So there we go. I have proven that it is a parallelogram first, and now I just need to write up that it is a rectangle as well. So we have quadrilateral GLOV has, oops, that S is too far away, has diagonals that are congruent. Therefore, GLOVE is a rectangle. Again, as you recall from the notes, you can either separate out these paragraphs or these sentences, and you can write it just like I have, where I proved it's a parallelogram up here, and then I showed that it was, I wrote out that it was a rectangle down here, or you can take those sentences from the parallelogram and stick it right over here and just do one 4-sentence or 5-sentence paragraph. It's totally up to you. Does not matter. As long as it's in there, you're good. All right, question 2. We got quadrilateral bunt this time, and we're proving it's a rhombus. Rhombus this time. Alrighty. So again, if you want to draw your picture so that you know where your diagonals are, be my guest. There you go. All right. So for rhombus, it's the same thing. You need to show parallelogram first. So that's my step 1 every single time. Prove parallelogram. And again, I don't need to do, I don't have to do the other choices for parallelogram. Now I'm not forcing you to do anything. You choose which one that you want to do. And like I said, the majority of you are going to choose to do the two midpoints instead of the other four equations that are required for the other three options. So I'm going to stick with that. I'm just going to move this guy up here so that I can label my diagonals, which as you see is B and N. So I'll do that in red, X1, Y1. And N is going to be X2, Y2. And then I got U and T. I'll do that in blue. X1, Y1, X2, Y2. All right, let's start with the red. So I want the midpoint of BN. Let's write in that formula. Average of my X's, comma, the average of my Y's. All right, plug-in time. We got x1, which is 1 plus 4, and also the same thing for oh wait, yeah, same thing for my y's. 1 plus 4, and then 1 plus 4. 1 plus 4 divided by 2, and also 1 plus 4 divided by 2. So obviously this is going to give me the same exact point, which is 5/2. Okay, blue time. This is the midpoint of, that's a W, not a U. I want UT. There we go. So this one, I won't write the formula out this time because I already did. I got 0 plus 5 divided by 2, and then I have 5 plus 0. So this, again, is going to give me the same point, and it just so happens to be the same exact midpoint as my other diagonal, which is exactly what I want. So now all I got to do is just write out my sentences, which is what you did, followed by what does this prove. So this is quadrilateral bunt has diagonals that bisect each other, and therefore quadrilateral bunt is a parallelogram. Boom, done. Proved it's a parallelogram. Excellent. Now we're dealing with a rhombus this time. So if you refer back to your list of how to prove a rhombus, you need to choose one of two options. One pair of consecutive sides are congruent, or the diagonals are perpendicular to each other. Well, since we've dealt with the not the but the diagonals already to prove a parallelogram. Let's keep going with the diagonals since we're already used to the numbers and how they work. So let's just prove that these guys are also perpendicular to each other. Okay, so step number 2, we need to prove rhombus. All right, so now I need small m. So you really want to make a distinction between your small m, which is slope, and your capital M, which is for midpoint, okay? So you can see this one is clearly bigger than this guy. You need to make that clear for everybody to read. Otherwise, they're thinking you're doing the midpoint, and people will get confused. Even though they will see the formula next to it, you want to make it really clear right off the bat that it is a lowercase m. And even if you want to go so far as to do if you know how to write cursive, if you know how to do a small m in cursive, if you want to distinct that way, be my guest. That's totally fine. I write in cursive, and that's what I would do, but I know that lots of people can't read cursive, so I just do it in print. But anyway, so again, we want the slope of our first diagonal, which is BM, so I throw that down in the subscript still. And let's remind ourselves what the slope formula is. And there we go. Now we can just plug in So y2 for my reds is 4, and I'm subtracting 1. And that's the same thing for both of them, since it's 1, 1, and 4, 4. So I get 4 minus 1 on the top and the bottom. 4 minus 1, 4 minus 1, which is, this is going to give me 1 because this turns out to be 3 over 3. So I got a slope of 1. Now I got to do the slope, small m of ut. I won't write in the formula this time. Let's just plug it in. So I got y2 for my blues, which is 0, and then minus 5. 0 minus 5. And now my x2 for my blues is 5, and I'm taking away 0. So just flip-flop them. 5 minus 0. So this is going to be negative 5 divided by 5, and this gives me negative 1. And those guys are negative reciprocals of each other. So bam, I have proven that the diagonals are perpendicular, aka they form a right angle with each other. Now all I got to do is just write my sentences and I am good. I'll do them over here to the right. So we have quadrilateral bunt has diagonals that are perpendicular. Therefore, bunt is a rhombus. And that's it. Again, just like before, you can choose to write it out separate like this, where I have my sentences down here for step 2, and then I have written up here my sentences for step 1, which is up here. Or you can write all of these sentences together as one big paragraph at the end. It does not matter. All right, so that's it for the formal proofs. Let's check out this number 3 here. Given quadrilateral PQRS, that is a rectangle, all right? Which of the following is not true? Okay, so we got a rectangle. So the first one is, let's draw a picture of it so that we can get a glimpse of this. So rectangle P, Q, R, and S. So we got QR, which is this side, is parallel to SP. Well, that we know is true because it's a parallelogram. And because it's a parallelogram, both sides, all the sides need to be parallel to opposite sides need to be parallel to each other, not all sides. Opposite sides, which is what QR and SP are. Those are opposite sides and they are parallel. So that is true. So choice 1 is done. So next we have PQ, which is this side right here at the top, is perpendicular to PS. Well, if you look at your list to proving a rectangle, you see choice 2 says that prove you must show that one right angle exists in your rectangle. Well, if something is perpendicular to each other, then there exists a right angle. So that is also true. So choice 2 is gone. Now we have PR, which is this diagonal right here, and QS. Those things are congruent to each other. Well, what does it say in our list? Number 1 says in a rectangle, diagonals are congruent. That's one stipulation to prove that something is a rectangle. So that is true in this sense. And PQRS is a rectangle, so that is also true. Let's just check the last one since we know that it has to be 4, but let's just check it. PR, which is our diagonal, and QS, so we're still dealing with the diagonals, those are perpendicular, and that is one of the stipulations that you need to prove if something is a rhombus, not a rectangle. Okay, so it is choice 4. Alrighty, and that's it. I know this was a very long video, but I hope that it really helped you out. As always, be safe and be healthy, and I will see you guys next time. Bye.